In problem number 18, we're going to have to utilize both conditional proof and indirect proof. The problem starts off innocent enough. Let's just take a look at what we've got here. We've just got two premises to work with, and they are both fairly complex. We've got a lot of busting up here to do. We're going to have to go through a lot of steps, it seems, to break apart lines 1 and 2. And the conclusion we're after is K and L, horseshoe, not N. So again, no need to really deviate from our basic rule. Do we want to do conditional proof or indirect proof? Well, the conclusion's got a horseshoe statement in it, so the way to go, on the surface at least, seems to be conditional proof. So let's start there. Indent, assume the antecedent of what you're after. So the antecedent here would be both K and L, assumption conditional proof. And this is easy enough to work with. Main operator is the dot, so we can simplify, do a common simp, and there's your L. So that's 3 simp, and then again combining 2 steps, 3 com, followed by the simp, and we've got our L. So far so good. We're making all sorts of progress. With 4 and 5 now at hand, we can do, first of all, 1 and 4 modus ponens, and then we can do 2 and 5 modus ponens, 4, 6, and 7 respectively. And we're making some progress in busting up lines 1 and 2. For 6, we get everything to the right there, the horseshoe, everything contained in brackets, M or N, horseshoe, P and Q. And then the consequent of line number 2 for our line number 7. We get Q or R, horseshoe, S, and not N. So great, we're off to the races here. Great start to the problem, but of course the question now is, what can we do with lines 6 and 7? And the answer seems to be not a whole heck of a lot. We seem to be at an impasse. So when this occurs, and you might intend to very well see a problem quite similar to this on the test, when you become stuck in this section, it's usually kind of a tip-off that you need to take on an additional assumption. So let's reevaluate what it is that we're after. Let's take stock of what we've got and what we need. We've assumed the antecedent, and so we're now after the consequent. The consequent is not in it. So let's do now an indirect proof within our conditional proof. We're after not in, so let's assume the opposite, the negation of what we're now after. So we're after not in, the negation of that would be not in, which we know, of course, is just simply in. So I'll indent again, right in the middle of my conditional proof. I'll assume n, thus beginning an indirect proof, assumption indirect proof. So now I've assumed the opposite of what I'm after, and I need to arrive at a contradiction. So what can I do now with that n? Well, n proves to be useful because out of the n by itself, I can now create the antecedent to 6 via addition. And I'm going to combine 2 steps in one, m or n. The first step here is a addition, which would get me n or m, and then I've saved a little time here by simultaneously doing the com, reversing the order of the disjuncts. Now by creating in line 9 the antecedent to line number 6, I can immediately do 6 and 9 modus ponens, which will get me for line 10, the consequent here, P and Q. With P and Q now at my disposal, I can get out the Q, which will allow me eventually to create the antecedent this time to line number 7. So again, combining 2 steps, I get the Q. 10, first of all, com, flipping the order of the conjuncts, and then simplify. And I wanted the Q, so I can create via addition the antecedent to 7. So Q or R, and the justification 11 addition, and that now allows me to get out for line number 13, the consequent of 7, S and not N, S and not N. And now I'm going to extend this onto page number 2. Now I've got the makings of a contradiction. My original assumption was N, and now here, the second conjunct of 13, I've got its negation, I've got the not N. So I just need to go get it. Easy enough to do that. I can do 13, com, and a simp, fairly routine. There's my not N, and now I'm ready to build the contradiction. 8 and 14, 8 and 14 conjunction. There's my contradiction for line 15, N and not N. I've arrived at the contradiction, so I'm allowed to get out the opposite of my original assumption. My original assumption was N, and so I get out the opposite of that, the negation of that, not N. So my justification for my indirect proof, which I've now completed, all of those lines, 8 through 15, indirect proof. And now I've got, if you recall, I'll take a look here at the original conclusion we were asked to derive. I've assumed already at the very beginning, I've assumed the antecedent. I've now gotten the consequent, so I'm ready to discharge my conditional proof by joining the first line of our conditional proof together with the last line, which is in fact the result of our indirect proof. So again, if we can keep track of all this, really a long proof, took 2 sheets of paper, joining together 3 and 16 via a horseshoe for line 17, unindent again, discharging our conditional proof, and we get exactly what we wanted, K and L, horseshoe not N, and the justification consists of all of those lines, all the way back to line number 3, let me go ahead and seal this off, all the way back to 3, down to line number 17, 3 through 16, conditional proof. So that's a nested proof. In this particular case, we've got indirect proof inside of a conditional proof. So in this section, we have an option between either conditional proof or indirect proof, or in this case, a fairly lengthy problem. In this case, we're utilizing both, one inside of the other.